Thank you everyone for coming watching my presentation. In modern communication systems, developing an antenna, especially an antenna array, it is very time consuming and expensive. Thus, it is desirable to have an array which can cover multiple bands, have wide bandwidths, and support dual polarizations, maintain the beam scaling capabilities. Thus, we propose this reconfigurable slot ring antenna. And pin diode switches are placed on top of the radiation surface. By changing the operation state of these pin diode switches, these antennas can either work as a slot ring antenna, this large slot ring antenna, at a lower band state, or it can be divided into 4 small slot ring antenna, working as a higher band antenna arrays. By doing this, we can achieve dual band operation. The 2 microstrip lines are placed here to excited orthogonal mode enable the dual polarizations. But the issue is that once the bandwidth increases, the mutual coupling between the 2 orthogonal ports becomes larger and larger. So in order to address this issue, we propose this diagonal feeding method. Each antenna element is excited at the horizontal diagonal polarizations. So by forming a 2x2 array, and each diagonal polarizations can have it can be excited appropriately. Then this 2x2 arrays can achieve either a horizontal polarizations or vertical polarizations or horizontal polarizations. This is very similar to sequential rotation method. By doing that, we can achieve dual polarizations, and fractal shape are introduced into the slot ring radiator apertures. Thus, to enhance the bandwidth, then we can achieve 2.5 to 4 GHz in the lower band state, and 4.2 to 7.2 GHz in the higher band state. But the issue is that since this antenna have pretty wide bandwidths, and a copper plate is placed behind the antenna to enable unidirectional radiations. But the bandwidth of this copper plate is pretty limited. If we for this design, the copper plate is too close to the radiation apertures, then it create a null here. You can see the gain at both side directions becomes smaller than 0. The 0 dBi at the around 2 GHz, which is which is due to the lower directivity at the both side directions. In order to address this issue, we propose a dual band AMC. We use a band stop FSS element and a copper plate to build an AMC structures. So this is the FSS, this is the copper plate. By doing that, we can have a dual band AMCs. Then we can achieve pretty flat gain performance at both operation states.